We're going to look at the multiplication properties of exponents. There's a couple rules. We're going to find out what those two rules are and how to use them, and then we're going to kind of combine them, put them all in one. So first off, there's two parts to these problems. You've got the base and then the exponent. When we use these multiplication properties that we're about to do, the base has to be the same. So here, x, and then the exponents can go together. Now, exponent of 4, exponent of 2, I've got a magic exponent that I don't see. That magic exponent is a 1. I'm going to put it there just as a placeholder so we know and we don't forget it. Now, I want to do something called, I want to rewrite this first problem in something called expanded form. Expanded means I'm taking this problem, I'm going to kind of make it a little larger. So what that means is, this exponent of 4 says I've got x multiplied by itself 4 times. So this really says x times x times x times x. Parentheses, we're multiplying something else. We're multiplying x and x. And then at the very end, we're multiplying one more x. When it comes to multiplication, it doesn't matter the order, it's just how many of something do we have. In this case, 1, 2, 3, 4, 5, 6, 7 x's. So I can rewrite that as just saying x to the 7th power. Now, is there another way I can do that without writing in an expanded form? Absolutely. Look at your exponents. 4 plus 2 plus 1 gives you 7. So when the base is the same, all you need to do is add the exponents. Okay, let's kind of take that to the next step now. I now throw numbers in there. The numbers kind of complicate them for a little bit, but we can ignore them for right now. Let's go back to what we already know. X and X. Multiplying straight across, I can multiply out of order. So let's kind of just look at that and that. Same base, different exponents. When I combine them, all I gotta do is add the exponents. 2 plus 6 gives me 8. So we use that, we use that. Now we have two other numbers, 3 and 5. They're being multiplied. Let's just go back to a regular old multiplication problem. 3 times 5 gives you 15. So you're going to break this up into two parts. You're going to do the variables and then you're going to do the numbers. All right, so that's the first rule. When the base is the same, you add the exponents. Things change when you now have an exponent being raised to an exponent. So to figure out that rule, we're going to rewrite this in expanded form again. So this exponent of 2 says I have two of these groups, x to the third and x to the third. That exponent says I have 3 x's. This exponent says I have 3 more. How many total x's are being multiplied in the end? 6. Now, how did I get there? When you have an exponent raised to an exponent, all you have to do is multiply those two numbers. So let's take it to that next step up. We know we have to multiply, but what happens when we have two variables? Well, first off, I want to know what my exponent is with the x, because this y only gets to 4. I've got nothing here. I do. It's just hidden. It's a 1. Now, I want to use this rule of multiplying 2 times. I want to do it to the x. I want to do it to the y. So I'm going to say x, 1 times 6 gives me 6. Y, 4 times 6, 24. All you're doing is kind of distributing that exponent. You're just multiplying them together. What happens when you have an exponent raised to an exponent raised to an exponent? Multiplication. Multiply these three numbers. 2 times 3 is 6. 6 times 4, 24. Done. So again, when your x's are next to each other, add the exponents. When you have an x and exponent to an exponent, you multiply. Let's kind of combine all that stuff. Oh, let's do one more of this, but with, with a negative in there. So we know we can do that. Multiply those exponents. You're going to get x to the 9th power. What about if I do that to just the 4, not the negative, just the 4. 4 times 4 times 4 is going to give us 64. And now I'm going to do this one more time, but to the negative. It's a negative times a negative, it's a positive, times one more negative is going to give us a negative, get a negative answer. All right, let's combine both of these rules for this big ugly thing. So take it step by step. Well, we know that right here, this is the same thing as here, so I'm just going to let's bring it right down. Now we got to worry about this. So parentheses, brackets, remember they're both the same thing. Brackets just mean parentheses, just to help differentiate what we're looking at. Let's figure that one out. Well, 2 and 3 is going to give me a 6, so I'm going to rewrite. And a lot of what we do is going to be rewriting. Let's take this 6 and distribute it to everything. So x to the 6th power, 2 times 2 is 4, again is 8, again 16, 32, one more, 64. 2 to the 6th power is 64. Now a negative being raised to the 6th power. Negative times negative, positive. Negative and negative, another positive. Negative and negative, positive. So we know we're going to have a positive 64. We don't need to show anything there. Bring all this down. So again, rewrite, rewrite, rewrite. Let's start with the x's. Now our x's are next to each other, like what we did over here. So add the exponents. 9 and 6 is going to give us 15. And when things start to get a little confusing, let's cross them out. Negative times positive, my answer is going to be negative. And now we got to figure out 64 times 64. Well, give me some room. 64, 64, 4 and 4, 16, 24, 25, placeholder, 24, 36, 38. Whoa. 6, 9, 0, 1, 4096. Yeah, that's a big one. Ladies and gentlemen, that's multiplying. That's using the multiplication properties of exponents.